You have checked for understanding. Hopefully you've nailed that. 4 out of 4, I'm hoping for everybody. All right, so we're going to dig into the data a little bit more here. Real quick though, they have this career connections. I want you guys to come back and look at this after you're done with the questions you have to answer for today. You're going to have a little extra time left, I think, and you can look at Allison Bumgart and what she does as a quality engineer. Okay, so it just gives you an idea of some of the different jobs out there involving engineering, because I don't think we're all very aware of how diverse a field engineering really is in the end here. All right, so what we're going to actually do now is look at the data from the launches. We didn't actually launch our devices to get this data. We're going to use some made up data that already exists. But pretending that we did for a minute here, we set out our giant coordinate grid, we launched, we tried to shoot for the origin of that coordinate grid, okay? The data that we collected is called a sample, okay? Because it's not every launch that this device will ever do. It's just a sample, a subset. If you click on this, that's exactly what it says, subset of the population of all possible launches that can be made using your device. All right. And what we're going to be using this for eventually in the next section or activity 114 is actually, or 115 is actually a project. And you're going to be developing a game target for your device that has 2 concentric circles. Okay, so we need to first figure out how to quantitatively determine accuracy and precision for a launch device. All right, so what we're going to do here is we're going to look at the data, the distance learning support here. We're going to look at the data they're going to give us. So if you click on that, okay, it's going to bring this guy up. And it's just talking about, okay, we skipped over this, but you were supposed to have previously tested this. We didn't get really a chance to, but we had this, should have had this giant sheet of paper, and we got together in teams and we launched our beanbags at it. And as we launched it, so there's the beanbag there with the green. We're launching paper balls a little bit different. But this beanbag here has the green dot, and then they mark that green dot onto their coordinate grid, and they keep doing this over and over again. And as they do it, they record not just the coordinate in a spreadsheet, but they also record the measured distance from the center to where that point is located. All right, and they just continued on. This was somebody's device, and they did 25 beanbag points. And so down below here, that's what you're going to see, is that these are 5 different teams, fictitious data results. Somebody actually might have done this. I don't know. I shouldn't call it fictitious. All right. But anyhow, just keep in mind when we're doing this that the origin right here at the center was the ideal location target. Okay, so when you're talking about accuracy, that's where we wanted to land, was right at the origin. FYI, you're going to want to use the Google Sheets version. You'll see the data down here when you want to go look at the data, which is coming up in a couple here. The Google Sheets is the version you're going to want to use. All right, anyhow, so you're going to want to look through these here and then take a minute, get out your engineering notebook for me, create a new page called Activity 114, and go ahead and answer these reflection questions in your engineering notebook. And then once you're done with that, come back to the video.